Today we're going to cover Chapter 8, Lesson 5 over the properties of trapezoids and kites. This is Becky. Becky recently graduated from the School of Architecture in the University of Princeton. Over summer, Becky got her first job as an architect and was excited for her first big project. She was expected to create a structure that had many abstract figures on the outside and the inside of the dimension. The outside was to be created as in the shape of a trapezoid, while the interior of the building to be created with a huge arc shaped like an isosceles trapezoid with many quadrilateral figured carvings on it, but mainly a kite. To help her with this very huge project, her friend Bob the builder, who happens to be a great architect, came out to help her out. To help them with their huge project, they turned into Becky's handy-dandy notebook to look into all of the properties of the trapezoid, isosceles trapezoid, and the kite to make sure they create the right structure. A trapezoid is a quadrilateral, which means it only has 4 sides. It also only has exactly one pair of parallel sides. This makes it different from the other quadrilaterals, like the parallelogram and the rectangle, which have 2 pairs of parallel sides. Also, the parallel sides of the trapezoid are also the base of the trapezoid. The 2 non-parallel sides that are left in the trapezoid are the legs of the trapezoid. Also, the trapezoid has 2 pairs of base angles. An isosceles trapezoid is very similar to the trapezoid. However, the isosceles trapezoid has legs that are congruent to each other and still has 1 pair of parallel sides. There are 3 theorems to remember for an isosceles trapezoid. If a trapezoid is isosceles, then each pair of base angle is congruent. Also, if a trapezoid has a pair of congruent base angles, it is also an isosceles trapezoid. And last but not least, a trapezoid is isosceles if and only if its diagonals are congruent. Now going back to the project, Becky has to make sure her bases are only 1 pair of parallel sides and that its base angles are congruent. Also, a key term to remember about the trapezoid is the mid-segment of a trapezoid. The mid-segment of a trapezoid is the segment that connects the midpoints of its leg. There is also a theorem that goes along for the mid-segment of a trapezoid. The mid-segment of a trapezoid is parallel to each base, and its length is 1/2 of the sum of the lengths of its bases. So, if we add the top base of the structure and the bottom base of the structure and divide that by half, you'll get the mid-segment. Let's work it out. Now, the top base is 30 feet long and the bottom base is 50 feet long. We add both the top base and the bottom base to get the total sum of 80 and divide that by 2 to get 40. Therefore, the mid-segment of the architecture that's being created is 40 feet long. Now, looking back at Becky's handy-dandy notebook, a kite, which is also a quadrilateral, is completely different from a trapezoid. A kite is a quadrilateral that has 2 pairs of consecutive congruent sides, but opposite sides are not congruent. It also has 2 theorems that follow it. A quadrilateral is a kite if its diagonals are perpendicular. Also, if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. Now to prove the last theorem, let's do an example. Becky has several kites along her architecture carved into her walls. One of the kites has angle A 100 degrees, and angle B unknown, and angle C 86 degrees, while angle D is unknown. We take the known factors and add them together, and we get 186. Now a quadrilateral has 360 in total. So we take 360 minus 186, and that equals to 174. And according to the theorem, we need to divide that by 2 because there are 2 congruent bases, so they equal to each other, and we get 87 degrees for angle B and D. With the help of all her crew and everyone, she was able to create her first architecture amazingly.